So here we go. Now you can see the changes. And this is what we call ocean acidification, the changes in dissolved CO2 concentrations in the oceans since the beginning of the Industrial Revolution. Okay, so look at the figures first. Okay, so again, get the pointer on. Look at the figures first. So what happened to the increase in atmospheric CO2? And you can see it has led to an increase in the surface layers of the ocean, because this is where the CO2 ends up. Okay, the surface layers of the ocean. Okay, you can see a little bit of a signal in the North Atlantic as you go into the North Atlantic deep water. Okay, but on a time scale of only 100 to 200 years, this change is relatively low. Okay, so you have to wait a longer time. What's the time scale of the deep circulation? Well, it's 1,000 or 2,000 years or so, and you can see some effects later on. So actually the atmospheric CO2 increases are too rapid to be stored away in the deep ocean. So you see big changes primarily in the surface ocean. Again, this is the cause of ocean acidification. Okay, and you can see it here in all oceans. So a little bit more information is that the oceanic uptake of CO2 accounts for approximately 1/4 to 1/3 of the CO2 released from all human activities since 1800. Okay? The CO2 released into the atmosphere, 1/4 to 1/3 has ended up in the ocean, and this has caused the changes on the surface of it. Okay? Without this uptake, the atmospheric warming effect would be more pronounced. Okay, so overall, the mean pH of 8.1 on the seawater scale is approximately 0.1 pH units less than the estimated pre-industrial values. So this relates to a 30% increase in the number or concentration of hydrogen ions. Okay, so you understand a little bit more about what happened to the CO2 released by humans, how much ended up in the ocean, and where did it actually end up in the oceans.